before we do a question on center of pressure and thrust calculation of ship's bulkhead, like curvilinear surface is like a bulkhead of a vessel. When vertical ordinates are given, I've already done one video on horizontal ordinates. The vertical ordinates question solution is a bit different. So before we do a question, I would like to go through the working procedure. What is the derivation behind the formula which we are using? So, like we see here, ship's bulkhead. It's a vertical bulkhead, and DT is the tank top of the bulkhead. We pick up a very thin vertical strip, like a vertical ordinate on the bulkhead. So it's a very thin vertical strip with the width equal to dx, very small width dx, and length of the vertical ordinate or the vertical strip is y. So it is what will be the area of this vertical strip with the width dx? Area will be like this. We can assume it as a rectangle because it's so thin. The strip is so thin that we can safely assume it to be a rectangle. So length is y and the width is dx. So area will be y times dx. Y dot dx. This will be the area of this thin vertical strip. What will be the first moment of this area? So first moment of the area about tank top will be area of the strip multiplied by the distance of its centroid from tank top. Okay, so when we are taking moments, the levers are always from the centroid to the axis about which we are taking the moments. So we are taking moments about tank top. So from tank top to the centroid of this strip, the distance will be half of the length of the strip, because it's a very thin rectangle, and the centroid of a rectangle is halfway its sides. So the length of the strip is y, and the centroid will be y by 2 from tank top. So area is y dot dx. Y is the length of the strip and dx is the width of the strip. So length into breadth is area of rectangle, and y by 2 is the lever for the moment, that is the half length of the strip. About tank top, remember it's about from tank top the moments are being taken. So y into y becomes y squared dx divided by 2. So when we are doing this calculation with vertical ordinates, we use Simpson's rule as usual. For the area, no normal Simpson's rule will be applied, like we have the ordinates called y, and ordinates are multiplied by Simpson's multiplier, and we get area function, and then sum of the products SOP, and we find the area. The first moment of area is you can see is y square function. Y square function is we multiply the area function with the ordinate itself. So area function is y dot dx. So we multiply y dot dx with y. Y is the ordinate itself, the vertical ordinate. So it becomes y square function. That is the moment of area. But remember, this moment of area y square function, at the end when we do the sum of the products and we do the solution for first moment of area by Simpson's rule, the SOP must be divided by 2. You can see why in the working we are dividing the sum of the product by 2 is because of this reason. The derivation is here, that y square dot dx divided by 2. So that division by 2 comes from here. Now the next column after y square will be y cube. How we arrive at that? So what is the moment of inertia of this vertical thin strip about tank top? About tank top, what is the moment of inertia of this vertical thin strip? So that's always a moment of inertia about axis passing through the centroid of the strip IgG plus area of the strip multiplied by d square. D is the distance of the centroid of the strip from tank top. We are taking moments from tank top, so d is the depth of the centroid of this vertical strip, thin strip below the tank top. So since it's a very thin rectangle, it's a very thin strip which can be easily assumed to be a rectangle. So IgG, which is the moment of inertia about the axis passing through the centroid, is Lb cube upon 12. So here in this case it will be dx y cube upon 12. So dx is the width and y cube, because the axis is parallel to the tank top passing through the centroid of this strip. So the dx y cube upon 12 plus area of the strip, which is length of the strip y multiplied by width of the strip, which is dx. So y dot dx is the area of the strip, and the depth of the centroid from tank top, which is, as I explained, half of the ordinate, half of the length of the ordinate y by 2 square. So you simplify this dx y cube upon 12 plus dx y is multiplied by y square, becomes again y cube. So dx y cube divided by 4. So if you simplify this, you will get dx y cube upon 3. So y cube is the moment of inertia function. And when we do the Simpson's rule, the sum of the product of this column, y cube column, is divided by 3. So you must have seen in the working that first moment of area SOP is divided by 2, and second moment of area, which is moment of inertia, the sum of the product of y cube is divided by 3. So that's how we get the moment of inertia about tank top. Now we have moment of inertia about tank top. We have calculated that with Simpson's rule. But for calculating center of pressure, depth of center of pressure, we need moment of inertia about water surface, WS. For that, only directly from moment of inertia about tank top, no, I cannot go to moment of inertia about water surface, because I must find first the moment of inertia about the axis passing through the centroid of the strip. So what will be the moment of inertia about tank top, which we just found that that's always equal to moment of inertia about the axis passing through centroid IgG plus AD square, area of the bulkhead, and this D is the distance of the centroid below the tank top, because this is moment of inertia about tank top, TT. So the D is the distance of the centroid below the tank top. So from here you can see that what will be IgG, moment of inertia about the centroidal axis. That will be moment of inertia about tank top, ITT minus AD square. That is one equation. So we got now from here moment of inertia about the centroid. Then we get moment of inertia about water surface. That will be equal to IgG plus AD square. So IgG we have found here in number 1, moment of inertia about the axis passing through centroid plus area of the immersed surface area of the bulkhead And now this D is the depth of the centroid below water surface. In equation number 1, D was depth of the centroid below tank top, because that was tank top. That was the two axes were, one was passing through the centroid and one was at the tank top. Now we had our second axis, which is parallel to the axis through the centroid, is at water surface. So D is the depth of the centroid below water surface. So in both number 1 and 2, D will be different. So this is how we get the moment of inertia about the water surface. And for center of pressure, the normal formula will be used, IWS upon AD. This purpose of this video was only to clarify what is the working principle. Like in the sum of the products, for first moment of area, we have to divide by 2, and then the sum of the product SOP or moment of inertia column, we have to divide by 3. That's the explanation given. Okay, so now I will put another video. Now immediately straight away we go on to doing a question from past MMD papers involving vertical ordinates.